Welcome to the office. We want to take a look today at cyclic groups. Now, we should have an idea already of what a cyclic group is, but what we want to do here is to go ahead and provide some further details on that. So let's take a look at an introduction to the section here. All right. So what are we going to look at in this section? Let's see here. Try to give us an idea of the things that we're going to see. So we want to look at some elementary properties of cyclic groups. You'll find this as a kind of a title under which we make some notes here later in our lecture notes, of course. And essentially what we want to take away from this with some elementary properties include that every group is abelian. So I'm going to try to give you essentially a preview of everything that we're going to talk about in this section. And then we'll actually talk about them in another video. So elementary properties, every group is abelian. Of course, not every group is abelian. Every cyclic group is abelian. There we go, cyclic group. Every cyclic group is abelian. Hey, that's a really cool property of cyclic groups. Excellent. The next thing that we want, let's see here. We're going to talk about the division algorithm in this section. Now, you may be familiar with the division algorithm already. If you are, excellent. Maybe you can skip that video or whatever. We'll barely talk about the proof of it, but just to familiarize ourselves with the division algorithm. The division algorithm isn't what is actually important. What we want to take away is the ability to use it in a proof of that a subgroup of a cyclic group is cyclic. So any subgroup of a cyclic group is cyclic. You can't come up with something that is not cyclic as a subgroup of a cyclic group. So that's a very nice property as well. There is a corollary to that, and it specifies that all of the subgroups of the integers are precisely NZ, right? Yeah, NZ under addition. So that's all of the subgroups. We'll take a look at that, of course, in a little bit. Let's see here. We want to move on then. Well, this is still within the same thing. So still within elementary properties, we have a definition of a greatest common divisor. Now, the idea with the greatest common divisor, it's going to be defined by or as the generator of a particular group. However, the reality is that the greatest common divisor with this weird definition is just the same thing that we've always known a greatest common divisor to be. All right, so we're still talking about integers. What's the greatest common divisor of two integers? Well, what's exactly what you already know it to be. All right, so then there's structure. So the next kind of title we will work within is the structure of cyclic groups. So we want to talk about that a little bit. And really, this is just a classification. This is just a classification of all cyclic groups. In particular, if you have a cyclic group, what we want to take away, or the thing that we have for the structure of cyclic groups, is that every cyclic group is either congruent to Zn modulo n, right? So addition modulo n, working with those numbers 0 through n minus 1, right? The modular arithmetic that we talked about earlier. So every cyclic group is either isomorphic to that, or if it's an infinite group, then it's actually isomorphic to the integers under addition again, but just all integers under addition. So every cyclic group is either congruent to all integers, or it is congruent to integers modulo whatever. Okay, now modulo n. If it's got 10 elements, it's mod 10, that sort of thing. All right, and that's actually it for that. And then we want to talk about subgroups. subgroups of cyclic groups. We already said a little bit about subgroups of cyclic groups that they're cyclic. However, we're going to determine, or we're going to find that every subgroup, and this is true regardless of cyclic or not cyclic, but every subgroup, the order of that subgroup is going to divide the order of the group itself. So if we have a group of order 12, then when we create a subgroup, we could have a subgroup of order 2, order 3, order 4, order 6, because those are all of the numbers that divide 12. And it actually works out that we will have all of those. Now, for cyclic groups, you will have a subgroup of that specific order, and there is only one subgroup of that specific order. So for subgroups of cyclic groups, divisors of the order of the group is maybe what you want to say here. You're going to be able to find a subgroup of that particular order, and only one. You'll find exactly one, no less, no more. So that's really cool. It's a way for us to recognize what groups we can get. Now, that idea is not necessarily true for groups that are not cyclic. If it's not cyclic, I don't think that you're guaranteed to have an element of any particular order, a group of any particular order, and you might have multiple of that order. So that's a little bit interesting. You think about our the Klein 4 group, the 3 elements that are not the identity element both generate subgroups of size 2, right? Those are cyclic because we're using an element to generate it, but we have these groups that are, well, they are cyclic, and there's set within something that is not cyclic because the Klein 4 group is not cyclic. But then there's 3 groups that all have the same order of 2. And again, that would not be the case for a cyclic group. There would only be one. All right, and that's going to allow us to draw some nice diagrams called subgroup diagrams. Here's what the group is, and then you can kind of split that off into what the subgroups are. So that's essentially all that we're talking about in this section. So we have a few elementary properties of cyclic groups that we want to talk about. Here they are. We're going to talk about the structure of cyclic groups, the fact that they're all pretty much the same. If you have 2 cyclic groups and they're the same order, they're going to be isomorphic to one another because they're completely characterized by the properties that we've given here. Yeah. So they'll all be of that particular form. And here's a further discussion on the subgroups. Yeah, so that's it. So those are the things we're going to be talking about. Honestly, you could probably look at the book, take a quick glance at the theorems, and start working on the homework if you understood the things I just said. But if you'd like to take some good notes, then let's go ahead and take a look at all of the things. There's lots of videos, of course. So join me back here in the office, and let's have some conversation. See you in a bit.